Hello friends, I welcome you all to this class. This is mathematics class, and today we have another important topic to consider: Taylor series. Now we want to look at how we can find a Taylor series expansion of a particular function about a point given to you. Now we say that the Taylor series expansion of a function f of x about x equals a is given by f of x equals f of a plus f prime of a over 1 factorial multiplying x minus a. So if you have first derivative 1 factorial raised, then you have x minus a raised to power 1, then plus f prime prime at a, that's second derivative at a, divided by 2 factorial raised to power, you now have multiplying x minus a raised to power what? 2, plus third derivative of f prime prime at a divided by 3 factorial multiply x minus a raised to power what? 3, right? So you can guess the pattern. Next is what? Fourth derivative of f at what? A divided by what? 4 factorial multiplying x minus a all raised to power what? 4. Next we have plus fifth derivative of f at a divided by what? 5 factorial multiplying x minus a all raised to power what? 5. That's how it goes on. Now let's look at this example. Find the Taylor series expansion of f of x which equals cosine of x about x equals pi over 2 up to n equals 5. Let's write our f of x first, given f of x is equals to cosine of x. Now by the formula we need to get what? F at a. Our a is here is what? Pi over 2. That's the point given to you, is your a. Pi over 2. So which will be cosine what? Which is cosine pi over 2. So I'm putting x for what? Pi over 2 in my cosine. And what is cosine pi over 2? Pi over 2 is 90 degrees. So that's 180 divided by 2. And cosine 90 is what? 0. So I've gotten f at a. So we need to get the f prime at a, right? But let's differentiate this. F prime of x will be equals to, if you differentiate cosine, you get what? Negative sine x. You now do f prime at I want to do f prime at a. Our a is this point, remember? Pi over 2. F prime at pi over 2 will be, you put pi over 2 in this, negative sine pi over 2. Then that will give you what? What is sine pi over 2 is 90 degrees. Sine 90 is what? 1. And we have negative here. So that's negative 1. F prime, we need to get the second one. F prime prime at a. Right? So let's get the second derivative. F prime prime of x. We first of all get f prime prime of x. So this first derivative, you differentiate it again to get what? Second derivative. So if you differentiate this again, differentiate sine, you have what? Positive cosine. But since we have negative here, so our answer will be negative cosine of x. Then you now do f prime prime at a. I want to do f prime prime at a. Our a is this point, pi over 2. That's f prime prime at pi over 2 we'll put pi over 2 here. Negative cosine of pi over 2. As we said earlier, cosine pi over 2 is 0. This is 0 because pi over 2 is 90, cos 90 is 0. So for the third one, third derivative, right? So for the third one, we now have f prime 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 of x. That's third derivative of our function. So this is our second derivative. So if you differentiate the second derivative again, you get the third derivative. So if you differentiate cosine, you get what? Negative what? Sine. But since we have negative here, so negative, negative, positive, so it will be positive sign x. Then you now do f prime 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 at a. That's this one at a, and our a is what? Pi over 2. Pi over 2 for this question. So you now put pi over 2 here. You now have sine pi over 2. Sine pi over 2 is 1. That's sine 90. Then they say up to n equals 5, right? So we still need to do what? Fourth derivative and fifth derivative. Fourth derivative. So you come to this third derivative, you differentiate it again. So differentiate sine. If you differentiate sine, you get what? Negative cosine of x. You now substitute your point in this fourth derivative. So that's fourth derivative at a. That's this point now. Our point is pi over 2. So you put pi over 2 here. Negative cosine of pi over 2. And this gives you what? 0. Because cosine pi over 2 is 0. Next, you do the what? Let's do the fifth derivative here. Fifth derivative. The fifth derivative of our function f. You come to this cosine. This is our fourth derivative. Differentiate fourth derivative to get fifth derivative. Get negative sine x if you differentiate cosine. And fifth derivative. The fifth derivative at a. Our a is pi over 2, right? X is they say about x equals pi over 2. Remember, that's our a. So pi over 2, and we are going to put pi over 2 here. So I have negative sine pi over 2. Sine pi over 2 is 90, and sine 90 will give you 1. And have negative here. We have negative 1. So we are good to go. By Taylor series expansion, f of x, which equals to cosine x, equals. So let's make use of this expansion I've written down here. So because of that, I will extend this expansion. So we can substitute the points, right? Let's substitute the points. So I've changed those point a to the point given to us pi over 2. So that this f at pi over 2 gave us what? From there, it gave us 0. So we have 0 plus f prime at pi over 2. Let's check. F prime at pi over 2. See it here. It gave us negative 1. If you do negative 1 divided by 1 factorial, 1 factorial is 1. Negative 1 divided by 1 is negative 1. Then next, let's look at the next one. We have f prime prime at pi over 2. Let's check it. F prime prime at pi over 2 gave us 0. So 0 multiply this quantity, you have what? 0. Right? You have 0. Then the next one is what? The next one is f prime 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 at pi over 2. So f prime 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 at pi over 2 gave us what? 1. So if you put 1 here, so you are going to have plus 1 divided by, if you put 1 here, 3 factorial is 3 times 2 times 1, that's 6. Divided by 6, multiplying x minus pi over 2 all raised to power 3 plus the fourth derivative of f at pi over 2. Let's check it. Fourth derivative of f at pi over 2, it gave us 0 plus 0 plus the fifth derivative of f at pi over 2 gave us what? Minus 1 divided by 5 factorial. Have minus 1 divided by 5 factorial. Then multiplying what? Okay, let me leave this one 3 factorial. Multiplying x minus pi over 2 all raised to power 5. Then plus dot dot dot. But they told us to stop at 5. So we'll stop at 5 there. So this is the required Taylor series expansion of this function cos x about x equals pi over 2. So thank you so much for being part of this class. I'm expecting you in our upcoming class. Bye.